Welcome to qiphyedu. Today we'll be looking at computer science A2 level, paper 32, May-June 2022. Alright, let's start. Okay, so for the first question, it says data types can be defined using pseudocode. The data type building record is defined in pseudocode as the code on the bottom. A variable building register is declared in pseudocode as declare building register, building record. Write pseudocode statements to assign 1067 to the building ID of building register, house to the building group of building register. Okay, so what we do here is that building register is now declared as building record, which is a composite data type. So what we do here is we just take building register, put it onto the left, put a dot, put building ID, put an arrow. This one is integer, so we don't need to put in any inverted commas, just put numbers in. And then the bottom one will be building register dot building group. And then this one is string, so we need to use inverted commas like such. Okay, so this is the answer. Right, B, the type definition for building record is changed. The data type for building group is changed to an enumerator type, building type with values of house, bungalow, apartment, and farm. So the data type for building group, so this one is declare. Not declare. This one is not declaring variables here. We need to create another type. So now we just put type building. This one is building type because it's enumerator type building type. So type building type equals, this is enumerator data type, so we need to include house, bungalow, apartment, and farm. So that will be this. Right, close the bracket. This is the answer. And then 2, we need to write a new declaration for building group in pseudocode, so we just need to declare building group as building type. Right. 3, we need to write the new pseudocode statement to assign house to building group or building register. So now what we do is just write building register dot building group we assign house to it. Okay, done. Then C, the program is to be rewritten using object-oriented programming. The data type building record is to be changed to a class building class. The properties for building class are building ID, building group, all these things. And all the properties are set to private. For example, private price last sold is real, and write the declaration is pseudocode for owner name as private. So so just now owner name is string. So what we should do here is just put private. Okay, put owner name as string. Okay, and 2, explain why the properties have been set to private. What we need to do is that the reason why it's private is because in class we need to make sure that it can only be accessed by the classes methods. So we just put in to ensure attributes can only be accessed by the class or methods, and to enforce encapsulation. Okay, so this is how I get 2 marks. And then 2, a decorative language used to represent the following facts about a school, and these clauses have the following meaning. Right, 1, 6, and 14. More facts are to be included. Sam studies history and Nina is his tutor. Write the additional clauses to record these facts. So we do here, we just put studies because it says Sam studies history, so we just put studies, and then all the names are in small letters, so just put small letter, and then put history. Then for tutor, because there's tutors here, so Nina as his tutor. So if you look at the clauses here, 14 says that Alan is Kim's tutor, so here we just put tutors, and then Nina is his tutor, so just put Nina here, and Sam. Right, that's that. And B, using the variable student, the girl studies student history, returns student Freya, Ahmed, Kim. And now we need to write the result returned by the girl studies student geography. So those who study geography would be Freya and Hua. So student here we put Freya and Hua. Alright, that's how we get the answer. And C, write the goal in using the variable x to find all the students who have a tutor that teaches them. For example, Hua has Alan for tutor and also taught mathematics by Alan. So find all the students who have a tutor who teaches them. Okay, so for example, teachers, you can just put in two random variables, so you just put R and S, okay, for example, and then X here will be the student, so then so let's say for example the R here, right, would be referring to a teacher, and then it's teaching whatever subject that we see just now. Then studies, and who is studying what. So for example, in this case, right, X is the person, and then studies S subject. The teachers here would be R would be that tutor, and then S would be the subject that's being taught. And then here we just put tutors. So here the tutor here will be tutor R, and then is actually teaching X. Right, so this is the answer. Then 3A, okay, before that, the TCP IP protocol suite has 4 layers. The application layer provides user services and identifies 2 protocols used by this layer. Describe the use of each protocol. So one of the protocols for for application layer is actually FTP, also known as file transfer protocol, which is used to send and receive files over the network. If you are familiar with website building using web servers, and if you use WordPress and all those, you roughly know how to use what FTP means and how it's being used. And then for protocol 2, there will be, for example, it can be POP3, it could be IMAP. These are all email protocols that is used to transfer emails to and fro. POP3 is used for, but basically for POP3 and IMAP, it's both for receiving emails, and then there's another one is SMTP, which is used to send emails. Okay, so here I'm just going to put in SMTP, send emails, as it is a push protocol. For the POP3 and IMAP protocols, these are pull protocols to take the message down, whereas SMTP is push it to another person. So it is a push protocol. Okay, and then now we need to identify 2 other layers of the TCP IP protocol suite. So first one, we can say transport layer. We can say it handles packets. Okay, and just like that, you can get 2 marks really, because it's really the main point. The second point, we can say internet layer. This one we can say you can put 2 if you want to. Handles data transmission using IP address. Using IP address. And provides the optimal route. Provides optimal route for packets to be sent. Packets to be sent. Alright. Then 4, the following syntax diagram shows the syntax of a variable, an unsigned integer, a letter, a digit, an operator, and an assignment statement. Okay, so A, the following assignment statements are invalid and state the reason in each case. Okay, so let's look at variable. Variable is a letter and unsigned integer. So x1, x is included, 1 is included. But unsigned integer is you can choose to have 1 digit or you can have 2 digits or only 1 digit. So x1 is correct. The equal sign is also correct, so we can just put correct for that. Y is included for variable, and the 2 is also included, so that's fine. But then the problem here would have to be the last variable, which is 12. So here we can just say that because there's no letter in front, so that's why it's invalid. So 12 is not a valid variable because it does not contain any letter. Does not contain, oh, actually not any letter, but more like this. It does not contain a letter in front. Okay. And then for this one, the problem with this one is that it doesn't include an unsigned integer. So Z is invalid. Z is invalid because it does not include unsigned integer. Okay, that's the answer. And then B, we need to complete the backwards null form for the syntax diagram shown. Okay, so letter has been completed, which is x, y, and z. Variable would be letter and unsigned integer, so we just put letter and unsigned integer side by side. Then unsigned integer would be 1 digit or 2 digits, so it could be like this. The vertical symbol here, I don't remember what it's called, but then it means all basically. It could be 1 digit or 2 digit. Then for digit here, we have 3 digits, which is 1, 2, and 3, so we just put it like that. Then for operator we have plus, minus, and multiply. So this one will be plus or minus or multiply. Okay. Then for assignment statement, it could be, it has to be variable, and then equal, and then variable, operator, and variable. So we just put this. Okay, that's that. And now the syntax of an assignment statement is changed to allow each of the variables on the right hand side of the equal symbol to be either a variable or an unsigned integer. I need to draw a syntax diagram for the new statement of the assignment statement. So if originally the assignment statement looks like this, but now it says that you can allow each of the variables on the right hand side of the equal symbol. You can choose for it to become variable or an unsigned integer. So it's basically everything here, but there's another option here for unsigned integer. Like that. Okay, then goes down, and then again, basically. Like that. Then, so what we can do here, we can just mimic the graph on top. So just put something like this. Variable, and then equals. Oops. Then this one is variable. Then this one is operator. And then the variable. n, and then here we put unsigned integer. Okay, so like that. Let's go up. Okay, then same for here. Let's do something like this. Down, done. This is how it looks like. I'm gonna adjust it a little so it looks much better. Right, now we need to write the backers now form for a syntax diagram. So what we do is we just take assignment statement. Then you look something like this. Two colon and then one equal sign, and then variable equals to variable operator variable, or variable operator unsigned integer or unsigned integer operator variable, and finally unsigned integer operator and unsigned integer. Okay, done. 5. There are 4 basic categories of computer architecture: single instruction, single data is one architecture, and now we need to identify the 3 other categories of computer architecture. So the other 3 will be single instruction, multiple data, followed by multiple instructions, single data, and multiple instructions, multiple data. So the first one, we're going to talk about single instruction, multiple data. So it's basically, it uses uses CPU, uses processors of this uses processors that are executing the same instruction but using different data sources or data sets in this case. And the second one is multiple instructions, single data. You can also put the abbreviation in the back if you want. This one will be put SIMD. This one is MISD. Uses processors that, oh, this one is not E, just realized, SORS. Uses processors that execute different instructions. Uses many processors in this case, we need to be more specific. You can execute different instructions, but use the same data set. And then finally, we have multiple instruction, multiple data, multiple instructions, multiple data. Which is MIMD. Uses many processors that execute different instructions and uses different data sets. Okay, so that's that. And then question 6, a logic circuit has two inputs, A and B, and two outputs, E and F. This is a half adder, and you realize that for this particular logic gate, this one is XOR, and then this one is AND gate. Okay, so A, B to E. So if it's XOR, 0 XOR 0 you get 0, and 0 and 0 you get 0. Then 0 XOR 1 you get 1, 0 and 1 you get 0, and then 1 XOR 0 you get 1, 1 and 1 you get 0, 1 XOR 1 you get 0, and 1 and 1 you get 1. So that's the answer. And then name of the circuit is half adder. The purpose of each output, the purpose of E is to calculate the sum, because 1 plus 1 you get 10, right? But then the 10 would not be shown until you use the AND gate to show that it is a 10, because the role of the AND gate here is as a carryover bit, to show the carryover bit. So the role of the XOR gate is to show the sum. So 1 plus 1 you get 0 basically for that particular row, but if it's 0 plus 1 you get 1, something like that. So purpose of E is as sum, and purpose of F is as carryover bit basically. And 7a, a digital signature is used to validate the authenticity of an electronic message. In order to produce a digital signature, a digital certificate is required. State how a digital certificate is obtained. Well, a digital certificate is requested by inquiring the certificate authority the public key and relevant details are also sent to the CA. If the CA has verified all details, it creates a digital certificate alongside, actually not alongside, but then digital certificate that includes the public key, includes the given public key, and then encrypts data sent to with the CA's public key. Okay. Then B1, we need to explain how a digital signature is produced before the message is sent. Before the message is sent, the message is hashed with hashing algorithm. To produce a message digest. The digest is then encrypted with the sender's private key. To form the digital signature. Alright, then for 2, explain how the digital signature can be checked on receipt to ensure that the message has not been altered during transmission. Okay, so the message together with the digital signature will then be decrypted with the receiver's private key. Because you need to remember that for messages sent to somebody, you always encrypt it with the receiver's public key. Alright, so private key, then the digital signature received is decrypted. Because you need to remember that just now it says that the message, the digest is encrypted with the private key of the sender, so you need to unlock it with the sender's public key to retrieve the digest. The decrypted message received is hash with hashing algorithm to reproduce the message I just received. Not digest, receive. Both of the digests are compared, and if both of them are the same, the message has not been altered. Okay, so just to recap, the message and the digital signature is decrypted with the receiver's private key, and then the digital signature received is decrypted with the sender's public key to retrieve the message digest, and then the decrypted message is hashed with hashing algorithm to get the message digest from the received message, and then both of them are compared, and if both of them are the same, that means the data is not tampered with, nothing is wrong with it. Alright. Then for 8, a binary search or linear search can be used to look for a specific value in an array. And then A, we need to complete the Stochastic algorithm for a linear search. So, right, declare mylist, declare max index, declare index found, and declare value to find. This one will be integer because it says value, so it's an integer value. And then input value to find. Found we get false, index we get 0, and then for max index would be 9 because the upper bound is 9. And then we repeat, if mylist index equals value to find, then found equals true, and if, and then index will be index plus 1 until found or index more than max index. If it's found, then output value find position index, else output value not found. Alright. Okay, so basically it is a linear search, so value to find is an integer, you input the value to find, you put false to the found variable, index is 0 because that's the lower bound, and then max index will be your upper bound. You repeat until found equals to true. In this case, it's found equals to true basically, or if your index is more than your maximum index of 9, and then if found, then you output what position, else you just output value not found. Because if you cannot find it, that means your found will still be false. Alright. Then we just take the necessary conditions for a binary search. The list has to be in order. Basically like A all the way to Z, for example. Then describe how to perform a binary search. First, we need to find the middle index. You need to see that this one is linear search, this one is binary search, is different. Binary search uses a different approach. It has a middle index and a lower bound and upper bound. So define the middle index and check the value of middle item in the list to be searched. If the value is the one to be found, if equals search for item search for is found, if the value is the one to be found, then search is completed. If not, if the value is greater than the item searched for, discard half of the list that does not contain the search item, because you need to remember it's in order. So let's say you get a number that's 55, and then you want to find the number 57 and it's more than that, then you can discard everything that is basically equals or less than 55. So we can discard half of the list. That does not contain. And repeat the steps until it's found. Right, that's for that. And then 3, explain how the performance of a binary search varies according to a number of values. Basically, if the number of items increases, the time to search for the value, or the time to search for the list, and this is part of big O notation. So if you look at C, compare the performance of the algorithms for binary search and linear search using big O notation. Linear search is basically ON, and binary search will be O log N, like this. Time to search increases linearly in relation to the number of items in the list for linear search, and logarithmically for binary search. And one more mark, we can just say that time to search in linear search increases much slower than time to search increases less rapidly for binary search, not linear search, because it's using logarithms, so it's much slower. Search list in binary search much slower than linear search. So if you use let's say for example log2 then it's 1, but if you use like log2 4, then you get 2, but if it's linear search, you'll be 4 seconds instead of 2 seconds. So yeah. State the reasons for including exception handling when writing a program. Basically to trap runtime errors and prevent the program from halting. Unexpectedly. For example, because it's 4 marks, we need to add one more. And then to produce error messages. For example, file not found. You can put in other examples as well, for example, divided by 0 or end of file, for example, right? For exception handling. Exception handling is like, if let's say you go through this process of looking through the file, but then you cannot find the data because it already reached the end of file, then that will be exception handling, saying error. Or you can say that the file cannot be opened. That's also another reason to use exception handling. And also when there's logical errors like dividing by 0, which is not possible, you give you an infinite number, that could also result in exception. That could also mean that exception handling has to kick in to tell the person that's using a program that there's an error with the value that you put in, for example. So yeah, that's the reason for exception handling. Okay, and then this is the end of this paper. I hope you guys find this video helpful. Do share this video out to other people who may need help with computer science A2 level. As always, I hope to see you guys again in the next video. Till then, this is qiphyedu. Goodbye.